Okay, so in this video, we are going to start to include some gravity and adding some being able to jump and kind of realistically go up in the air and then fall back to the ground in processing. So it's going to look something like this. This is something that students always request, and it's a little bit tricky to include. It requires a little bit of physics, just some like kind of like velocity and acceleration, and then it does require like a little bit more coding using like vectors, which aren't really big deal. It's a way of just kind of putting our x and y coordinates together into one place. So in this video, we're going to go through how to make that happen, make it jump up, and then fall down. And you see what's happening here is it's jumping up, it's reaching its apex, and then it's going to fall down. As it falls down, it's falling down at an increasing rate. So yeah, that's something that we can include in our game. And I think you can take this, you can also do like a simpler version of this, but this is something people request, so I thought I would show how you can make it. All right, so getting started, we have our ellipse, create an ellipse, it's called hero. I just create it kind of like roughly in the center of my screen towards the top, and then we're just displaying the hero. So when we do this, we're going to get this kind of appearing at the top. What we're going to do in here, the first thing we're going to do is we're going to start creating some p vectors. And like I said in the intro, a p vector is just a way of keeping track of kind of some x and y values. So I'm going to actually make 3 of these. I'll make 2 of these to begin with. I'm going to make one p vector that's going to keep track of our position. Oh, and I just need to declare it up here. I'm going to declare that, and then I'm also going to do p vector, and I'm going to say velocity. Okay. Down inside of our settings, we'll do our initial setup here. We'll say position is going to be equal to a new p vector, and this is just kind of like where should our location be at to begin with. I'm just going to make it match these values up here. So we'll say the initial value is just going to be 1,000 and 100. I could just do this a lot of different ways. And then velocity, what I want to do for my velocity is I want to make, to begin with, I'm just going to have my ball up there, and then I'm going to have it drop down. So maybe this will be a couple videos, maybe it'll be 2. I'll just put the ball up there. I'm going to show it dropping just with some velocity, and I'm going to add an acceleration later. But what this means is that I want my ball to just travel straight down. So that means I really don't need to move it in the x at all, and I just need to move it in the y. Right now, just setting up these values isn't going to do anything. Just declaring these does nothing. We need to actually like include this in our code. So I'm actually going to also include a method called public void update. And this is where we're going to update the position of our hero. Okay, I'm going to need to call this every time in my loop. Okay, so update. What is update going to do? We need to set the hero's x and y position. I guess that's really the last thing. That's what we're going to need to be able to do. We're going to use position. We're going to use our vector position to figure out kind of where the thing's located at. And I'm kind of working in reverse here. Like I'm going to finish by setting up the hero's x and y. And really what I need to do, again, kind of working backwards here, is I need to first, above this, kind of figure, okay, well, what should my position be? What I'm going to do here is I'm going to take my current position, and then I'm going to add velocity to it. So it's really, and this is where p vectors come in really in great use, because we're able to add them together very easily. So we can do position plus, or add, velocity. And so if you think about this, all this is going to do is like our original position was at location 1,100. And maybe I can show this without even updating the position at all. Let's just run this right now, and we should see our ball just kind of staying in the center. That's because we're constantly looping through here. We are updating, but we're just setting it to the location of position x, the x part of the position, and the y part of the position. And that's just 1,000 and 100. So nothing is really happening. What I need to do is I need to update this to say that take my position and then add however much my velocity is. However fast I'm moving, just take that value and add it to my position. And so just by adding that one line of code here, we should see our ball is starting to drop. Oof, not perfect. Let's maybe add into our draw. Let's make sure we're doing background. Let's say background 200. We'll put that like this, and we'll try that again. Okay, now we see a ball kind of smoothly dropping. But what I notice about this is that it's dropping at a steady pace, right? Which is okay. That is one thing that we might want to do, but it's not really increasing in speed. And I think for getting our jump, we really have to have some sort of acceleration. So acceleration in this case is basically the velocity should not stay steady over time. Right now, our velocity is just stuck at, go down by 5 each time. But really what should be happening here is our circle should be falling at a faster rate each time. It should maybe drop by 5 the first time, down by 5 pixels, and then by 6, and then by 7, and then by 8, and then by 9, and that's going to make it appear to drop like faster on the screen, and it's going to accelerate over time. Okay, so we are going to introduce a new p-vector, and this p-vector is going to be called acceleration. Okay, we are going to initialize it in here. We're going to say acceleration. It's going to be equal to a new p-vector. And in this case, we still want the x to be 0. Again, you could mess around with this in your code. I don't know, maybe you want to have something kind of moving left and right. I'm just having something drop. So I'm going to say that my acceleration downwards, my acceleration left and right is 0. And my acceleration downwards, if we do this at a very large number, we have to think very small, because if we are calling this method 30 times a second, we are calling this update method 30 times a second. If we mess with velocity too quickly, I'm going to try and zoom in here. Hopefully you have not been blind looking at that. But if we try and call acceleration, if we try and change velocity by too much, we're going to see this thing shooting off the screen. I might show an example of that. Let's put this as 2, just as an example. We'll come back to this. We're going to set acceleration to be 2. Okay. Now inside of our update, same way that we were updating our position vector by velocity, so we're basically modifying position by velocity. In this case, what we need to do is, we need to modify velocity. It needs to increase by whatever is stored in acceleration. Okay? So as we loop through here, to begin with, velocity is going to be 5. Great, the thing is going to move. Our velocity is going to be 5. Well, we're going to add 2 to it, so I guess that'll be 7. The position will be increased by 7. Okay, so we're going to go down to 107. We'll set the position. We'll run this loop again. Now velocity, 7 last time. We're going to increase it now by 9. So this now is going to shift down by 9. Next loop through, we're at velocity. We're again going to add velocity. Now velocity is 11. This thing is shifting 11 pixels. And next time we do 13 pixels, and then 15, and then 17. And you're actually going to see this is going to end up making this thing really shoot off the screen very quickly. So you can see maybe it's not too bad. You can't really see it on the screen, but it's not kind of like that beautiful, the arc we had before was very kind of, it would kind of move a little bit slower than that. So we want to adjust these values down. We could do 1. I do want to kind of move on from this, make sure I'm not spending too much time on this. But we can see it's a little bit faster. Yeah, not too bad. We probably want to put this down into a decimal value. And so we're going to say in here 0.3. If you say 0.3, so here's a little bit of annoying processing stuff. Processing it doesn't use doubles, which is our traditional kind of decimal point. It uses floats, which is just basically, it's still a decimal, but it just takes up less memory, and that's great. But it's a little bit annoying in so basically what I need to do, it's saying here that, p-vector doesn't accept a double, it should be getting in a float. All we need to do here is just put an F at the end of this. And that will say it's 0.3, but store this as a float, not as a decimal. It's a little bit tricky, but that's something we're just going to have to include. Just straight up, you're going to have to include F in there. Now if we include this, we can see that our ball is dropping at a much more sedate pace. Let's go back to this. We can change this even down to 1. Okay, so 0.1, you can see it's really much more gradual, much more visible. And so you can actually notice that hopefully accelerating on the screen. Okay, not too bad here. I think we covered the basics of doing this. We are incorporating acceleration. Hopefully it's not too bad. I know there's some kind of complex ideas in here about using p-vectors, are a little bit new. Doing some of this acceleration might be a little bit new. But just think about the position is getting affected by velocity, but how fast you're going will affect how much you travel in each frame. Acceleration will affect how much, how does the change from one frame to the change itself? So how much are we moving it by 5 pixels each time? Are we moving by 5, then 7, then 9? So hopefully that's kind of the value of acceleration, is we're moving by a greater rate each frame due to acceleration. Okay, so now what we need to do in the next video, we're going to include some jumping. And basically, it's going to be pretty straightforward. It's going to include a lot of the same stuff, but we are just going to add a little bit more related to making sure things on the ground, and then when we hit spacebar, we're going to go up and then come back down. But it's pretty straightforward, pretty similar to this. All right, so in the next video, I'm going to talk about adding in some jumping, and yeah, that should wrap things up.